right, my darlings, it is lovely to see you today on Monday, December 12th. It is a pleasure to be here. Miss Gray is not feeling really great today, so what I have done is I've posted the nurse's extension on that. So if Mrs. McGrain says, call the nurse, then that's what you're going to do. I want to remind everybody, including Logan, that you should be securing your devices at this moment because the bell rang. Your paper device there, Billy, I need you to put away your phone, please. That means I want to have all of your AirPods, earpods, cell phones, headphones, all of that stuff. Please make sure that you put it away so it doesn't jeopardize your success. If we look at our question of the day, it says, how does convection work? So if you can please get your notebooks open and write down that question of the day, I would greatly appreciate it. And then we're going to go ahead and discuss your thermal energy project, because I got several emails this weekend saying, Ms. McGrain, I'm not really sure, blah, blah, blah. So what I did was I created a little kind of outline, if you will, kind of outline rubric. So if you want to pick this up on your way out, you can do that. And I'll just have this be due on Wednesday. So if you're somebody that's like, I already did it, awesome, and you printed it out and you want to hand that in, great. I also made a little rubric kind of outline for the infographic, if you would rather just make like a little infographic on that. So they will be here for you so that you have a little bit more guidance as far as what you should be doing. And again, we'll have that turned in Wednesday. But if you finished it, you can just make a pile. All right, so your question of the day for Unit 5 on plate tectonics is, how does convection work? I am now going to be quiet and I will put up 1 minute on the board if I can find my phone, and then you will have some silent reflection on what it is that you think. This is from our reading that you did on Friday. So, and your time starts now. On marks, get set, go. Nice to see you all, by the way. Got a lot of people gone in the building today. Have you noticed? Asa is here. Hey, Asa, I almost marked you absent, man. I apologize. What's up, Peyton? But I didn't. For those of you who need a little handle on your time, you got about 20 seconds, and we'll turn to our pair share partners and share our thoughts out. Ethan, you can turn and talk to Alex. All right, there's our time. So if you could please turn to the person near you and talk about, hey, how does convection work? On your marks, get set, go. 15-second countdown. I don't know. Alex, that's so like grade school. Okay. Terrible. I don't know is not an effective answer, right? Try. Don't just say, I don't know.
Actually said, I don't even know.
I don't even know. Let's go ahead and turn it this way just a little bit, please. Thank you. Give me hands up in the air for those of you that want to just give it a try, even though you might not know exactly. From Friday, what do we need for convection cycles to work? Yeah.
Hot air.
Does it have to be hot air?
No, it doesn't have to.
So you need heat. Okay, so we need heat. Okay, tell me what the heat does. Why do we need heat? No, not you. Tell me what the heat does. No, not you. What's the heat do? You read it on Friday. What's the heat do? Why do we need heat? What's the heat doing? Thanks, man. It warms stuff up, which does what to the stuff? Like, what stuff are we heating up? Yeah.
It like transfers energy and like it makes the molecules like expand.
Yeah, but why are they expanding? What are they doing in order to expand? It's about molecules, and they are eventually going to expand. But that way. Yeah, what are they doing? What are the molecules doing?
They're rising.
But why are they raising up after they expand? Ethan?
Because they get less dense.
Yeah. Why? Yes?
Because they speed up.
Yeah, they speed up. They move really fast. So you heat molecules, and the molecules move really fast. Okay, so I'm going to go ahead and draw a picture of that. I'm going to have some of these little molecules, and these are going to be my little symbols saying that they're starting to move really quickly. If you cool something off, it doesn't move around really quickly. It's just barely moving, right? That's ice. That's what makes it solid. But if you heat it up, those molecules start moving really fast. Now, Billy, I'm going to ask you one more time, put that book away, otherwise give it to me. Now what we need to do is we need to go ahead and say, let's talk about Newton's third law of motion. Turn with your pair share partners, let's see if you can even remember what Newton's third law is. This is from last year. First law, second law, third law. What do we think the third law is? Ready, set, go. Third law of motion, third law of motion, third law of motion. Newton's third law, third law, third law. How about this? For every action,
There's
an equal and opposite reaction. Okay, so then we're going to go ahead and do this and say third law. And we're going to go ahead and say if these molecules bump into each other because they're moving so fast, it's like you probably don't even know what a mosh pit is. Do you guys know what a mosh pit is? Okay, so imagine a mosh pit and people are moving around really fast. Somebody bumps into you. You go in the opposite direction. So third law means molecules bump into each other and move apart. So they move apart. If we look at this box right here and then we look at an equal sized box so that they would have the same volume, if I have a bunch of molecules in here that are packed in and I have these molecules that are kind of like moving and bumping into each other, you've got different molecules that have now moved out of this area. So you have a situation where this is going to be more dense. This is going to now be less dense. And now we can go ahead and start talking about why they're moving. What's up, Buttercup? Absolutely. So now we can start talking about why they are going to go ahead and move. Now we can start talking about convection currents. It's all about heat. The molecules start moving really fast. Third law says for every action there's an equal and opposite reaction, so the molecules bump into each other and move apart. And then we have an area that becomes more dense, or we have an area that becomes, I should say, less dense. And then that moves. So then less dense material, right? I mean, Asa said air, but it doesn't have to be air. It can be water, it can be liquefied Jose. Right? Whatever, as long as we get something warm enough and the molecules spread apart and move up. So then we could say this could be number 1, this could be number 2, this could be number 3. Less dense material rises up. Less dense material rises up. So if we're looking at a situation like this for convection currents, it would do something like this. And you need heat. The heat would be down here. And I'm going to say less dense because it's rising. It's not less dense because it's rising because it's less dense. Okay, now that's the part that goes up. Whatever goes up, Logan, whatever goes up must come down. So let's talk about the how do we go down from this. Turn with your pair share partner. It's like if you took a walk in the woods and this is how you got to a certain part, how would you go backwards and get out of the woods? Same way, but you go in reverse. So with your pair share partner, talk to me. If this is how things go rise up, how do they fall back down? Ready, set, go. Just retrace your steps in the opposite direction. If I want them to fall, right, this says less material rises up. I want more dense material to fall down. And then what do I have to do? Yeah.
You have to cool the particles.
I have to cool the particles. And so there has to be an area up here that is much cooler. If it is much cooler, then those molecules are not going to be moving really fast. Those molecules are going to be slowing down. And those molecules are going to start settling in next to each other, and they're going to become more dense, and then that particular area or material is then going to be falling back down. So it is more dense because of the temperature cooling, and then it makes it fall back down. Where it goes down to the bottom and it heats up, and then guess what happens? Molecules spread out, becomes less dense, rises up again. And you get a circulation current. Happens again and again and again and again and again until you change the temperature. Sound good? We're going to be doing that today in class. How? With some hot chocolate. We're going to do what's called the hot chocolate lab. I'm going to go ahead and set this up while you, let's get our table of contents set up first. So let's go ahead and get our TOC, table of contents. We'll get this set up for us. And it's going to take about 10 minutes to go ahead and do its thing. So we are in here, table of contents. Oh, it looks like last time we were together, my pen wasn't working. Let's see if we can get it working today. So I believe the last time we were together was at 12, oops, was that 12:8 that we wrote in here? And that was convection current, convection current reading. Today is 12:12, so let's go ahead and fill that in. We are going to do a lab. I'm going to do that lab as a demo, and it is called Hot Cocoa Convection. So that's what we're going to be doing today. We are going to be using hot chocolate as a way to learn about convection currents. Oops, that's not it. That's what I want. All right, so it says, in this investigation, we are going to look at the movement below the crustal plates caused by heating and cooling from below, and how this transfer of energy can cause movement on the crust of Earth. So we've done a lot with energy and transfer of energy on Friday. And again, I'm going to go ahead and put these out. I'll walk them around maybe while you're working to see who wants what for these little kind of organizers for your thoughts. So part A says set up the hot cocoa lab. We're going to pour water, and this would be like if you were going to be in your own, but I'm going to go ahead and just do it here. I'm going to crank that heat on so we get it nice and hot. I've got water filling up here, and then what I'm going to do very carefully is I'm going to fill this with a nice cocoa crust. I'm going to try to be as gentle as possible, but it looks like we've already got some of the cocoa falling down to the bottom. All right. Smooth that out on the top for y'all. Put a little bit more on there. Okay, I like it. I like it a lot. All right. So then what we're going to do is we're going to let that do its thing. I want to make sure that we are able to see that. So I'm going to unplug this, and we're going to plug this in so that hopefully we'll be able to get a good view of the top. Yay! And then we also want a nice view of the side. And I want it to be something so that we're looking at it like, oops, did I go too far? Okay, can you see the particles? You can see some particles starting to fall down. Miss McGurn! I just need a longer cord. All right, we can see some of the particles starting to fall down. Can you see that? Mm-hmm. Yes? Okay, awesome. Can you see it on the screen? Probably not. I'll shut the lights down a little bit. Maybe we can see that just a little bit better. All right, so that's going to be kind of what we're going to do. We're going to let that do its thing for a little bit and just kind of watch what's happening. I don't know if you can see up here, but you can see the bottom of the crust kind of being affected a little bit. And then you've got some particles. Why are these particles moving back up? Some of them are coming down, but look at these. Why are they moving up? Because the bottom's what? Because the bottom is hotter down here. We're going to let that do its thing for just a little bit while I hand back some papers for you, because it's going to take us about 10 minutes. So we'll keep our eye on that. We'll come back and check it out. But I want to make sure that you got some materials back to you, and I want you to let you go ahead and look at your exam. So I'm going to hand this back to Cooper. If you can hand that back to Cooper, I'd appreciate it. Here you go, Kayla, for you. And then I want to go ahead and have Zy, Billy, Peyton, and Lauren look at your exam. There's not very much of you left, but if you could go ahead and look, it's just you. So if you want to go ahead and look at that, that would be great. If you want to stay there or go someplace else. William, Ebony is not here, so that's for you. Hassan is not here. Jose, I want you to go ahead and see your exam. Could you hand that back, please? Kylie, Braden, and Alex. Could you hand that back to Braden, please? You guys go ahead and go to a table and look at yours. Here you go. You can check yours out. You got exactly the same one twice. And then Kendall, Maya, Cooper, there's yours. And then my A pluses, do you want to see your exams or are you good? You want to see your exam? Cocoa is always hydrophobic. Yeah, it is. If you put a scoop of cocoa and you put it like into water or milk, it won't mix very well. Rebel, did you want to see yours?
No.
Ethan, did you want to see yours?
Can you take the
Can you what?
the retakes?
You already did the research, right? When you are done with them, if you could please hand them back in. You missed our retakes, man. Could you please hand those up here, please, when you are done looking at them? Put them in a pile right here. And then also come up and grab the thermal energy heat transfer essay and then also the infographic if you want to do one of those, if you want a little help on that write-up. Go ahead and grab one or the other, please. This is from Friday what we did. We did the reading and then you were going to do a little essay for me or an infographic. And so this is essay, that's infographic. You grab one or the other. Yeah, no, you need to print it, honeys, so that I can have it. So we're going to have that due for Mrs. McGrain on Wednesday. So if you could please print that off, I would greatly appreciate it by Wednesday. That way I can get them all graded and back to you before we go on winter holiday. It's going to be great. Yep. Did you? Wow, good guess. What, honey? I'm so sorry. This is for the infographic on the project that we did on Friday. Did you look at Canvas on Friday? We're doing here on Friday, weren't you?
I have no idea.
Okay, so there was an essay to write, or you could choose to do an infographic, one or the other.
What's an infographic? Like, what's the difference? Like,
Infographic would be like, let me see if there's an example of it. That's an infographic.
like a poster or something?
Like, yeah, pictures with information underneath them. You know, like, hey, here's convection. You're still writing, right? You're still giving the information, but I think the essay is easier, but you do whatever. All right, so then we've got this doing its thing. While that's doing its thing, could everybody please, did I get everybody's exam back? Let's flip over the hot cocoa convection currents lab, please. Let's flip this over, please and thank you, and look at the back. This is what you picked up on the way in. Good? All right, so it says, what do you observe happening to the hot cocoa crust? Nothing right now. What can you observe causing this process? Nothing right now. And so let's go ahead and look at the draw a picture and label what you're seeing in the water with the beaker. Nothing right now, so we can't do that. Let's go to the front. We'll keep our eye on this so that we can do the back, but right now let's go on the front. Part B, while you're waiting for the water to heat up, complete the reading. You're going to dig a little deeper into convection currents by going to page 270 in the book that I put at your table, and you're going to answer the questions below. For example, what is a convection current? If you look, remember, good students know the tricks and the trades of a textbook. There will be bolded words and titles. Look for the title first, and then look for the bolded words in your reading. So turn to page 270. While you are working through that, and we're waiting for something to be moving and grooving in here, it would not be fair to do a hot cocoa lab if I did not bring you your own hot cocoa. So I made hot cocoa for everybody. I'm going to wheel out some hot cocoa with some marshmallows, and then we will go ahead and share some hot cocoa. Because
That's the only
it's
reason
a
I
winter
made those
holiday
glasses.
kind of thing. I just love winter.
That's the only reason I can use. Like I only show that for yeah. Let me just check.
Spilled a little bit of my chocolate. Now, I want to let you know this has milk in it. So if you're somebody that is like milk averse, where milk does not do very good for you, then we need to make sure maybe that you are not having this. All right, so I have got marshmallows, but I've got my food safe love for the hot chocolate. If you would like hot chocolate, come on down and get some hot chocolate. It is very hot. Let's make a line, please, so that not everybody is just crowding all over the place. Would you like some marshmallows? It's hot, be careful. Absolutely. We'll have some hot chocolate while we do our reading. Would you like some marshmallows? Oh, I'm sorry. I didn't even ask. I'm sorry. She want marshmallows. I'm so sorry about that. Huh? I didn't give you very many marshmallows. Is that what you said?
Yeah.
I gave you some marshmallows, right? And hot chocolate. Just ungrateful. Sorry. Some marshmallows. You're welcome. Would you like some marshmallows? Yes, everybody did. I think you're right. I just think that there's a lot of sickness going around. Oh, it changed. Now again, I told you there's milk in here, right? I put sweetened condensed milk in here to make it nice and creamy.
She said sweetened condensed milk.
Sweetened condensed milk. So it's nice and extra creamy fatty. Mm-hmm. I can't drink it because I can't have that. I am. It does suck, but keeps me away from ice cream. I keep forgetting to ask people, guys. I know some people don't like vegetables. You're very welcome. Thank you. Marshmallows? No marshmallows. Yep. Hot chocolate. Korean marshmallows. All right, how's our little water over there with our cocoa crap? Ooh, We really need to be looking at what's happening. When things go, they go kind of fast.
Can I get some marshmallows?
Me too, Alex.
No, ma'am. Just because you asked doesn't mean I have to say yes. I gave everybody marshmallows and I've got to give marshmallows to the rest of the level doesn't mean I hate you. All right, let's go ahead and see what's happening now. What do we see? Whoops, what do we see going on inside there? Not a lot because, oh, do you see the pieces going up?
Yeah.
All right. So let's go ahead and look at the back. Oh, I saw some pieces coming down. Let's go ahead and look at the back side. Could you please flip it over? It says, oh, I see these pieces too. They're moving up. Oh, I see these pieces. They're moving up. So we see something like this. Could you please draw that in your little beaker? And then we're also seeing some pieces come down like this. Well, that one kind of came straight down. Oh, look, that one went way up. These are going up. It's getting darker and darker, though, and harder to see. So please make sure that we label what we see going on here. This is the water. And then make sure that you put the crust at the top and label that crust. You with me? We should be on the back paper. Crust. I'm going to get rid of this now. Hey Billy, we missed you. We had some hot cocoa. You want me to get you some in a little bit? Bill? Lee? Yeah? Okay. All right, so now what we're going to do is we're going to start looking at the top of this, and it looks like already, what are we noticing kind of happening to our crust? What are we seeing happening? Nothing? What? It's getting wet, okay. How is that happening?
The water is getting hot.
Yeah, so where's the wetness coming from? From where? From the bottom of the crust. And how is it getting through the crust? What? You're whispering and I can't hear a darn word you're saying. What's happening? What's happening with the crust? It is getting heat. Heat's down there. Big deal. Why does that mean that this is wetness over here?
Pushing it upwards.
It's what's going upwards?
Water.
The warmth is going upwards?
The water.
The water is going upwards. I see that this is starting to open up a little. We've got movement down below. And so what's that doing to the crust? If things are moving up, do you think it's going to be bumping up against the crust and moving the crust a little bit? Maybe quite possibly. I'm anticipating we're going to start seeing some cracks open up. So we're going to go ahead and keep our eye on that. You keep reading on the front. I will go ahead and get Billy some hot cocoa. Billy, marshmallows or no marshmallows? Marshmallows? Okay, make sure though that you've got your hot cocoa lab out for me. Everybody should be on page 270 and 271 and you're working on the front side. I'll get Billy some. So Billy, I need to know if you're allergic to All right. Ooh, I start to see this is opening up just a little bit more. Do y'all know what you should be doing right now? You're kind of like doing your independent reading as we're working on this. We're sipping our hot chocolate. We're having a hell of a day. It is very hot. It's hot chocolate. Very hot. So it makes it yummy. Hot chocolate. Tell me when you start seeing those fissures open up.
The wet spots are expanding.
What?
The wet spots are expanding.
They are, aren't they? Yeah, they're getting bigger. That must have been a weak area in the crust, and then it's coming up through there. I'm thinking we're probably going to get, I can see this crack opening up a little bit more. I think this is going to start opening up a little bit more. I'm thinking maybe down through here, and maybe up through here we're going to start seeing the cracks open. This crack over here has become a little bigger. I'm interested to see what's happening there. You got to be careful with this because once this starts getting to a certain temperature, it could very easily go up all over. Volcano! Too much heat and pressure building up. If we look at the back side of this really quick, it says connect to your reading. In this lab, we had a hot plate, we had a beaker full of water, and we had hot cocoa mix packed along the top of the water in the beaker. What do you think each of these components represented in terms of the 3 layers of the earth? Which the hot plate?
Core.
The core, yeah. The hot plate was the core. So the hot plate was the core. What do you think represents the milk/water? Right, well, the mantle, William, the mantle. And then what then represents the hot cocoa?
Crust.
The crust of the earth. I can really see now the top starting to crack much more. This thing is just gonna, when it moves, I think it's gonna move really quickly. Wow, I don't know if you can see this or not. I'm gonna try to see the sides. Oh, I know it's upside down. Nope, how about we do this? Can you see? Can you see all that movement? It's like all of that material is rising up. Even like larger chunks are starting to move up. And that's actually what's really happening inside the earth. Wait. So we've got lots of cracks. This is getting bigger. This one's getting much deeper. This one's getting deeper. Oh, look at this big one over here. Cracking of the crust, cracking of the crust. Can you imagine places on Earth where this is really happening? Has anybody ever heard of areas that are opening up or cracking? What? Like the Ice Age?
Nope.
Absolutely. I can see some stuff bubbling up through here. There was something called the Siberian Flats, like billions of years ago. What's up, bud? Geysers. Geysers are areas that have a lot of water that is being superheated in the crust. Areas like Yellowstone National Park. Has anybody been to Yellowstone National Park? That's a super volcano. That is an area that is like one of the largest volcanoes in the world, and it is really close to us. If that volcano goes, we are going to experience something here. We're not going to experience lava flows, but we will probably be able to experience like volcanic bombs getting thrown our direction. For sure, we will get layers of ash. Layers of ash will like cover this area, ruin our agriculture. And it'll be thrown into a, what's called a nuclear winter. So yeah, it'll be like cold all year, which happened back, yeah, and then also the 1400s, where in London it was, people were ice skating on the River Thames in July. And, you know, populations crashed because there wasn't enough food for everybody to eat. So, but that is definitely something that, the Siberian Flats is something that opened up like a big fissure all the way across well, in Siberia. And for like, hundreds of thousands of years, lava was spewing out of those big cracks. All right, so that's it. How's the reading going? Great, are you done? Well, shut up then so you can continue it. Thank you. And then if you're like, I'm all done with the reading, Mrs. McGrain, I'm just now waiting to see what happens here, you can go ahead and start typing up your little essay if you want. Bubble, bubble, bubble. Wow, can you hear this? Can you hear that? I shouldn't have my face next to something so hot and liquidy. What's up? Yep, absolutely. This crack's getting deeper. Do you think, like in the earth, it takes a long time for something like this to happen in our crust? Long time. Magma in the mantle, it moves about as fast as your fingernails grow. So it travels really slow. Even though you've got convection currents happening, it's not happening this quickly. Those currents, which are like thick, sticky, kind of like liquid rock, are just slowly moving at like, minuscule amounts per year. So it takes a long time for land to crack open. And then when this starts cracking open, what do you think will happen to that land? Will they get closer to each other or will they move apart from each other? Yeah, they're going to be moving apart from each other. Has anybody ever heard of Pangea? No, not Pangea. Alfred Wegener? You have a question. Oh, okay, what? In the library? I don't know. What's the printer in the library called that you can print to?
Liberty Media or something.
Is it moving? Ooh, look! That one's really oh, look! Can you see it?
It's bubbling.
This one's starting to, oh, look! It's starting to move across. Now we've got some serious movement happening.
But look at the.
Look at them moving away from each other.
Continents.
That's continental drift, y'all! Plate tectonics, plate tectonics.
It's gonna blow up.
It's gonna be
Yeah, now I'm gonna turn that down.
It's gonna blow up. Dang. That's the whole thing.
Can you see it? And that's called Atlantis. It's sinking into the, no, it's not. But wasn't that cool when they started kind of like cracking and then they start separating away from each other? That's what's happening. Yeah, that's continental plate tectonics. Continental drift is what Alfred Wegener called it, but now we call it plate tectonics. Tecton for the Greek word of to build, building with plates. So there's that. All right, so now let's go ahead and look back and see what we saw happening. Part A, what do you observe happening to the cocoa crust that's resting on top of the water? What do we see happening? Cracked and moving away from each other. That could not have happened more perfectly. All right, what can you observe was causing the process that was below the crust? Get off your phone, log in. What do we see that was happening below the crust? Yep. Convection currents, yeah, the movement of the water, or we know it to be convection currents. So it says, please explain. Explain what convection currents are. The upward movement of the water, up and down movement of the water, if you want to say that. And then I think that we're good on that back side. Now you just need to finish your front side reading. For those of you that are at home, finish the reading at home.